Okay, so this is a technique called multiple reference frames, and it's actually being employed in H.264. This is where some of the largest improvement comes from. H.264, because you are. Now, do you have access to all these reference frames? Yes, you encode them before. You just store them in a buffer. Okay, so that comes at a computational cost. Okay, first of all, you need to spend a lot more time searching because you can search here, you can search here, you can search there. And second, you have to buffer all these frames. Okay, so that comes at multiple costs, and thus make 264 a lot more complicated to implement than say MPEG-1. Okay, what about other variations? You can make your block size variable. Okay, at this point, we're searching in this mode only. 16 by 16 square, we don't consider anything else, right? Now, but when you have object moving, sometimes you do not capture the entire object using one block, or a block a block might contain both background and foreground, right? The foreground moves, but the background stays. Okay, so in that case, you might need to split the block up. Okay, and that's why sometimes you can improve by choosing this mode, searching this guy independently of this guy, searching this guy independently of this guy, or searching 4 guys independently, or searching 16 guys independently. So these are the modes. This is also the motion model for H.264. And you have to, how do you find out what mode is the best? How do you find out what mode is the best? Okay, what do you have to do for the decoder? You have to send the mode over to the decoder. Okay, and if you decide to choose mode 4, you better send 4 motion vectors to the decoder. Okay, so that increases side information to trade off for residue energy. The residue should decrease all the time, but the side information typically increase. Okay, I bypassed this. This is a little. This is actually in MPEG-4, and it's based on the affine model. So obviously you have a lot more parameters to find out. Okay, some kind of global estimations. But the main point that I want to emphasize is that what we just discussed on block motion estimations is the key to state-of-the-art video coding. Whoever does motion estimation, motion compensation better will win. Okay, at least up to this point in time. Okay, and when we go back from the break, we're gonna start tracing back the history of video coding, starting from the earliest one to H.264 now, and you will see that everything from then to now, okay, is just minor variation of the same scheme that we have been talking about for the first roughly 2 hours. And from now on, we don't have, we will talk about video compression standards, so we're going to try to trace back the history of developments in this field, and hopefully we learn a few things along the way, okay? Maybe, first of all, differentiate the difference between different codecs, learn how the behaviors of different codecs, learn the way people engineer these things, okay? So this mostly is an engineering problem. It's not a mathematical problem anymore, okay? A lot of things that people do in video coding is very ad hoc, is very intuitive, works great, but as you can see, there's just not much mathematics that you can claim about anything, okay? A lot of times, all the choices that people make, all the thresholds that people come up with, okay, come from experimentation. Okay, people play around with a whole lot of test videos. Okay, find out the modes, the thresholds, the whatever the behaviors that give you the best performance, and then set it as the default. Okay, that's typically how the way things work most of the time. Okay, and so the process of establishing an international standard involves a lot of these experimentation steps. Okay, people do a lot of experimental simulations, exhaustively study a lot of options that they have and choose the one that seems to be consistently outperforming others. Okay? And that's why, as you can see, we have many different tracks of standards. Okay? There's some ITU, which stands for International Telecommunication Union. Okay? And these guys are mainly concerned with teleconferencing, real-time communications of video over the networks. Okay? So we have the H.26 series. Okay? H.26 series only deals with video. Only deals with the video part. There's another guy who deals with the audio to go along with it. Okay? As we will see in the next few slides. And then we have the AMPAC standards, which is a different body, a different group, a different set of international researchers. And the main goal here is for archiving purposes. So you store for storage, for long-term storage and playback. You might throw away the real-time constraint. Okay, you can take forever to do motion estimation here if you want to. Nobody's gonna care because we encode the video once. Okay, and as far as and if we can play back fast enough, then that's all we care about. Okay, so here you might have more flexibility in terms of designing the codec. And so the first international standards for video coding is called H.261, as you can see here. And it started in roughly about 1994, 1995. And that's what, 20 years ago? 20 years ago. Imagine that. A long time ago, right? Okay? I wasn't even in the university yet, okay? So they started a long time ago, and see how long it takes to finish the project. It takes roughly all the way to 1990, 6 years to finish the project. Okay? You know what people do during that 6 years period? Okay, when people try to establish an international standard, there will be a call for proposal. Okay? The call for proposal will go out. Let's say the ITU would like to seek expert opinions on establishing a new video coding standard called H.261. Whoever interested, whoever has the best technology and would like to contribute, please come to this particular meetings and submit your proposal. So there will be a lot of proposals, okay? And then they have committees, okay, that judge the proposal. And the way they judge it is they run experiments after experiments after experiments after experiments. Keep on running experiments, okay? And nobody really submit the entire video codec, okay? You only need to submit what is your expertise, okay? Maybe your expertise maybe it's motion estimations. Then you submit that motion estimation algorithms, okay? With certain input-output so that people can just put it into the codec and make it run, okay? But they have to test various modules, and they have to test various combination of the modules. And that's why it takes so long, okay? And so that's what happens when people first establish H.261. So after H.261, there's some overlap with AMPAC 1. Because these are two different committees, okay? There might be people participating in both, okay? And then, so this guy gets started, and as the later one, it has the advantage of knowing what this guy has been doing. So you will see later on that a lot of features in AMPAC 1 actually come from H.261 because people already know that this feature works well, that doesn't, okay, so on and so forth. So they borrow a lot of the popular features here, okay, and then work out their own,